Sneak a peek at the deepest and sharpest infrared image of the early universe ever taken, all in a day's work for the Webb telescope. For those who are not familiar with this space telescope, the James Webb Space Telescope is a space telescope designed primarily to conduct infrared astronomy. As the most powerful telescope ever launched into space, its greatly improved infrared resolution and sensitivity will allow it to view objects too old, distant, or faint for the Hubble Space Telescope. This is expected to enable a broad range of investigations across the fields of astronomy and cosmology, such as observation of the first stars and the formation of the first galaxies, and detailed atmospheric characterization of potentially habitable exoplanets. JWST was launched in December 2021 on a European Space Agency (ESA) Ariane 5 rocket from Kourou, French Guiana, and entered orbit in January 2022. As of July 2022, JWST is intended to succeed the Hubble as NASA's flagship mission in astrophysics. NASA released the first image from JWST on the 11th of July 2022, the oldest and highest resolution image of the universe. The NASA Goddard Space Flight Center (GSFC) in Maryland managed telescope development. The Space Telescope Science Institute in Baltimore operates JWST, and the prime contractor was Northrop Grumman. The telescope is named after James E. Webb, who was the administrator of NASA from 1961 to 1968 during the Mercury, Gemini, and Apollo programs. JWST's primary mirror consists of 18 hexagonal mirror segments made of gold-plated beryllium which combined create a 6.5-meter diameter mirror, compared with Hubble's 2.4 meters. This gives the Webb telescope a light collecting area of about 25 square meters, about 6 times that of Hubble. Unlike Hubble, which observes in the near-ultraviolet, visible, and near-infrared 0.1–1.7 micrometers spectra, JWST will observe in a lower frequency range, from long-wavelength visible light red through mid-infrared 0.6–28.3 micrometers. The telescope must be kept extremely cold, below -223 degrees Celsius, or -370 degrees Fahrenheit, to observe faint signals in the infrared spectrum without interference from other sources of thermal energy. It is deployed in a solar orbit near the Sun-Earth L2 Lagrange point, about 1.5 million kilometers or 930,000 miles from Earth, where its 5-layer, kite-shaped sunshield protects it from warming by the Sun, Earth, and Moon. Development began in 1996 for a launch initially planned for 2007 with a $500 million United States dollars budget. There were many delays and cost overruns, including a major redesign in 2005, a ripped sunshield during a practice deployment, recommendations from an independent review board, a threat by the U.S. Congress to cancel the project, the COVID-19 pandemic, and problems with the telescope itself. The high-stakes nature of the launch and the telescope's complexity were remarked upon by the media, scientists and engineers. Construction was completed in late 2016, followed by years of extensive testing before launch. The total project cost is now expected to be about $10 billion. And now, its first captured image revealed by NASA. Webb was able to capture this image in less than 1 day, while similar deep-field images from Hubble can take multiple weeks. If you held a grain of sand up to the sky at arm's length, that tiny speck is the size of Webb's view in this image. Imagine galaxies galore within a grain, including light from galaxies that traveled billions of years to us. Why do some of the galaxies in this image appear bent? The combined mass of this galaxy cluster acts as a gravitational lens, bending light rays from more distant galaxies behind it, magnifying them. This image isn't the farthest back we've ever observed. Non-infrared missions like COBE and WMAP saw the universe much closer to the Big Bang, about 380,000 years after, when there was only microwave background radiation, but no stars or galaxies yet. Webb sees a few hundred million years after the Big Bang. The James Webb Space Telescope is an international collaboration between NASA, National Aeronautics and Space Administration, the ESA, European Space Agency and the Canadian Space Agency. The Space Telescope Science Institute is the Science and Mission Operations Center for Webb. According to NASA.